In this episode, we focus on a truth that separates promising artificial intelligence, AI, ideas from systems that can survive real use. A design is not strong simply because it looks reasonable on paper. Early planning matters, but planning alone cannot tell an organization whether the system will support the intended workflow, whether users will understand it correctly, or whether the model will behave safely once messy reality begins to press on it. That is why strong AI design depends on structured evaluation before and during deployment, not just confidence from the team that built it. Use case evaluation, benchmarking, pilots, and testing give an organization ways to challenge its own assumptions while the design can still be improved. For a brand new learner, the key idea is simple. A responsible team does not wait for users, complaints, or headlines to reveal its weaknesses. It deliberately tries to discover those weaknesses earlier so the system can become narrower, safer, more useful, and easier to govern before trust in the system hardens around untested assumptions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good starting point is understanding what use case evaluation actually means. It is not a vague exercise where the team asks whether the project still feels like a good idea, and it is not limited to checking whether the model produces plausible outputs in a few demonstrations. Use case evaluation asks whether the proposed system still fits the real problem, the real users, the real workflow, and the real consequences surrounding that workflow. A system can appear technically strong and still be the wrong answer to the actual business need if it solves only a narrow piece of the process while creating confusion, rework, or new risks elsewhere. That is why teams should return to the use case again after initial design and before broader deployment. They need to ask whether the original purpose remains clear, whether the output still supports the right decision point, whether the humans around the system still understand their role, and whether the system is drifting toward a broader or riskier function than originally approved. This kind of evaluation keeps design anchored to purpose instead of allowing capability to quietly redefine the project. Use case evaluation becomes much stronger when it examines the real workflow rather than the ideal one imagined at the planning stage. In many organizations, the official process and the lived process are not exactly the same. Staff members create shortcuts, handle exceptions informally, work around bottlenecks, and rely on judgment calls that never appear in a process diagram. If the AI design is evaluated only against the formal version of the workflow, the team may miss the very places where the system will cause friction or where users will be tempted to misuse it because the real work does not unfold as neatly as the design assumed. This is why early evaluation should involve observing how work actually happens, not just reading procedure documents or listening only to managers. A system that looks helpful in theory may fail because frontline staff need context the system does not provide, because the output arrives at the wrong moment, or because the most difficult cases do not fit the narrow categories the design expected. A design grows stronger when evaluation exposes those mismatches early enough for the workflow and the system to be adjusted together. Another important part of use case evaluation is examining whether the system is likely to influence behavior in ways the team did not fully anticipate. This matters because AI systems do not just produce outputs. They shape pace, attention, confidence, escalation, and the way people think about their own judgment. A drafting tool may encourage staff to review less carefully because the output sounds polished. A ranking system may push users to focus only on the top of a list, even when the underlying signal is weak. A triage system may quietly redefine what urgency looks like by normalizing one kind of input pattern over another. These effects are design issues, not only user issues, and strong use case evaluation looks for them directly. The team should ask whether the design encourages blind trust, whether it hides uncertainty, whether it pressures staff to move too quickly, and whether it subtly shifts authority away from humans even when the system was supposed to remain advisory. A design that changes behavior without clear guardrails is often riskier than it first appears. Benchmarking enters the picture once the team has a clearer view of the use case and the kinds of performance that matter. For beginners, benchmarking is best understood as structured comparison. It helps an organization see how well the system performs against a defined baseline, a set of expected tasks, a previous version, or another reasonable approach to solving the same problem. The value of benchmarking is not that it produces one magical number that answers every governance question. The value is that it forces the team to stop relying on impressions and instead compare performance in a more disciplined way. A design team that says the system feels good is offering very weak evidence. A team that can show how the system performs on representative cases, where it improves on a simpler baseline, and where it still struggles is giving the organization something much more useful. Benchmarking strengthens design because it turns broad confidence into measurable comparison, and measurable comparison makes it easier to decide whether the current design is mature enough to continue, needs narrowing, or should be reconsidered entirely. The most important lesson about benchmarking is that the benchmark must reflect the real use case rather than a convenient but misleading test set. Many teams make the mistake of selecting benchmarks because they are easy to run, widely known, or flattering to the chosen model, even when they say very little about the system's actual task. A design cannot be trusted simply because it performs well on generic language or reasoning exercises if the real use case involves specific documents, sensitive decisions, ambiguous human inputs, or highly contextual judgments. Strong benchmarking, therefore, begins with relevance. The team should ask whether the benchmark cases resemble the data, conditions, and difficulty the system will face in real operation. It should also ask whether the benchmark includes the kinds of cases that matter most from a risk perspective, not just the ones that are easiest to score. A benchmark that ignores edge cases, messy language, low-quality inputs, or high-stakes ambiguity may give the organization a false sense of readiness. Good benchmarking is less about chasing prestige and more about choosing meaningful comparison points for the system being built. Benchmarking also becomes more useful when it compares the proposed system to something simpler rather than assuming the only question is whether the AI model performs well in isolation. Sometimes the best baseline is a manual process handled by trained staff. In other cases, it may be a rules-based tool, a traditional search function, or a narrower statistical approach that is cheaper, easier to explain, and easier to supervise. This matters because design strength is not measured only by the sophistication of the model. It is measured by whether the overall system improves on realistic alternatives in a way that justifies the added complexity, cost, and governance burden. A very advanced system that only slightly outperforms a simpler approach may not be the best design choice if the simpler approach is easier to test and safer to operate. Benchmarking against practical alternatives helps expose that reality. It encourages teams to ask whether the proposed design truly earns its place in the workflow or whether the organization is being drawn toward complexity simply because complexity appears innovative. Pilots add another essential layer because benchmarking alone cannot fully reveal how a system will behave once actual people begin using it in a real process. A pilot is a limited, controlled introduction of the system into a defined part of the operating environment, so the organization can learn under conditions that are realistic but still contained. The purpose is not merely to prove that the project can go live. The purpose is to surface the interaction between the design and the real world while the blast radius is still small enough to manage. A well-run pilot can reveal whether users interpret outputs correctly, whether the workflow timing makes sense, whether the handoff between human and system is workable, whether oversight points are too weak or too heavy, and whether the design creates unexpected burden in edge cases. Pilots strengthen AI designs because they expose the difference between laboratory confidence and operational reality. That difference is often where the most important governance lessons live, especially in systems that appear smooth during internal review but behave less predictably once real cases, real stakes, and real incentives are involved. A good pilot is narrow on purpose. It should focus on a clearly defined population, task, environment, and time period rather than trying to demonstrate universal readiness all at once. That narrowness is a strength because it gives the team a better chance of learning what is happening and why. If a pilot is too broad, The organization may see a mix of outcomes without being able to tell which design choices, user behaviors, or environmental conditions created them. A focused pilot makes it easier to notice recurring errors, review difficult cases, collect usable feedback, and compare what happened against what the design was supposed to support. It also gives leadership a more honest basis for deciding whether the design should be expanded, revised, or held back. The pilot should have clear entry and exit criteria, defined success measures, clear human oversight expectations, and a process for pausing or changing the pilot if signs of harm or instability appear. In other words, the pilot is not a soft launch disguised as learning. It is a learning environment designed to protect the organization from pretending it knows more than it does. One of the most valuable things a pilot can reveal is how people behave around the system, not just how the model performs. Users may rely on the system more quickly than expected, ignore it in the very cases where it could help, or develop workarounds because the official interface does not fit the pace of real work. Reviewers may feel that the escalation process is too slow. Managers may pressure staff to trust the system because it appears efficient, and affected individuals may respond in ways the project team never predicted. These are not minor side observations. They are central design findings, because an AI system is always part of a human and organizational environment. A pilot helps the team see whether the designed oversight model actually works under ordinary pressure, whether the thresholds produce too many false alarms or too much missed risk, and whether staff understand what the system should and should not be used for. The design grows stronger when those lessons are treated as feedback for redesign rather than as annoyances to be explained away. Testing is the broader discipline that ties all of this together, and it should be understood as much more than running a model on a batch of examples to produce a score. Strong AI testing looks at different layers of the system and different types of risk. It examines whether components work individually, whether the parts of the system interact correctly, whether the overall workflow behaves as intended, and whether the system still performs acceptably when inputs are messy, ambiguous, incomplete, adversarial, or simply different from what the designers expected. Testing also needs to examine governance properties, not just technical ones. Does the system expose enough context for oversight? Are logs reliable and usable? Do thresholds trigger at the right moments? Can users provide meaningful feedback? Does the system fail in a way that humans can notice and correct? These are design questions expressed through testing. If they are ignored, the organization may know the model's average performance while remaining dangerously uninformed about how the overall system behaves where the real risks live. A strong testing approach usually includes several kinds of cases rather than relying on one broad sample. Routine cases matter because the team needs to know whether the system is useful for ordinary work. Difficult cases matter because they often reveal whether the system's claims about capability remain credible when the task is genuinely ambiguous. Edge cases matter because they show how the system behaves near boundaries, where categories blur, context is thin, or unusual language appears. Misuse and stress cases matter because people will sometimes push the system beyond intended use, intentionally or accidentally, and a responsible team should want to know how brittle the design becomes under that pressure. Testing for these conditions does not mean the organization expects perfection. It means the organization is serious about learning where the design stops being trustworthy. That lesson is crucial for new learners. A design becomes stronger not when it avoids finding weaknesses, but when it deliberately tries to discover those weaknesses before users have to discover them the hard way. Testing also needs to be iterative if it is going to strengthen design rather than merely certify a snapshot in time. A one-time test can tell the team something useful, but it cannot reveal how the design changes as thresholds are adjusted, workflows are refined, new data is added, or users interact with the system in ways the original test set did not anticipate. This is why evaluation should be tied to decision points across the project, not concentrated only at the end. Early testing may challenge the basic use case or the choice of approach. Mid-stage testing may reveal where the architecture needs better controls or where feedback capture is too weak. Pilot stage testing may show that the interface is encouraging over-reliance or that the review process is too fragile under operational pressure. Each round of testing should answer a different question and support a different level of design maturity. When teams understand testing this way, They stop treating it as a final hurdle and start using it as a structured method for making better design decisions throughout development and rollout. The real value of use case evaluation, benchmarking, pilots, and testing appears when the organization is willing to let the results change the design. That may sound obvious, but many teams gather evidence only to defend the path they already wanted to take. Strong governance requires something more disciplined. If the evaluation shows the use case is too broad, the design should narrow. If the benchmark shows the gain over a simpler approach is too small, the organization should reconsider complexity. If the pilot reveals that users overtrust the system, the interface and oversight model should change. If testing shows fragile behavior in high-stakes conditions, the deployment plan should slow down or the use case should be constrained. Evidence that does not influence design is little more than decoration. The systems that become truly stronger are the ones built by teams willing to revise architecture, scope, thresholds, review paths, and even product ambition in response to what structured evaluation actually teaches them. The deeper conclusion from this topic is that strong AI design is not a one-time act of good judgment at the beginning of a project. It is the result of repeated encounters between the proposed design and structured evidence about how that design performs, where it fits, and where it fails. Use case evaluation checks whether the system still matches the real problem and workflow. Benchmarking compares it against meaningful standards and realistic alternatives. Pilots reveal what happens when the design meets human behavior and operational pressure. Testing examines technical behavior, workflow behavior, and governance behavior across routine, difficult, and risky conditions. Together, these practices turn confidence into evidence and evidence into better design. That is the heart of this episode. A responsible team strengthens its AI designs not by assuming they are ready, but by challenging them repeatedly, learning from what those challenges reveal, and making the design more disciplined before the wider world has to absorb the cost of its weaknesses.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.